Alright, we're reviewing for your rationals test tomorrow. What we need to do is always find a common denominator. The common denominator is 6. To get 3 to 6, you multiply by 2. You need to do the same up top. For this, you need to multiply 2 by 3. So multiply by 3 up top. Now the denominators are all the same. That means my numerators are all the same. 2x times 2 is 4x. 1 times 3 is 3. Now we're just solving for x. So I'll subtract 2x and subtract 3 from both sides. That means I'll get negative 3 for x. For these, my common denominator is 5x, so I just need to multiply this first one by 5 over 5. So I'll get 5 equals 1 minus the quantity, x minus 1. Distribute that negative. 5 equals 1 minus x plus 1. It means 5 equals 2 minus x, or that means that x will equal negative 3 yet again. Alright, on this one here, we need 2x squared as our lowest common denominator, so I need to multiply by an extra x for this one, and a 2 from this guy here. Now I have my common denominator, so 1 plus 5x will equal 2 times the quantity x minus 2. So that's 2x minus 4. So that means I'll have 3x will equal, if I subtract that over, negative 5. So x equals negative 5 over 3. For number 4, I already have x squared minus 1. That's factored as x plus 1, x minus 1. So that means I need an extra x plus 1 for this first term. And that means I need to multiply by both for this term over here, x squared minus 1 over x squared minus 1. Now I have my common denominator, so it will be 2x times x plus 1 plus your x minus 5 will equal x squared minus 1. That means this is 2x squared plus 2x plus x minus 5 equals x squared minus 1. I'll bring over the x squared by subtracting x squared. I need to add 1 to both sides. So that will become, well, I have 3x here. When I add 1, it will be minus 4. And now equals 0, I can factor that. X plus 4 and x minus 1 equals 0. So my answers are x equals negative 4 and positive 1. Something to pay attention to, positive 1 is an answer for the denominator. So this actually technically is an extraneous solution. If you notice that, that's great. If you just get the 2 answers, though, that's what I'm looking for right now. Alright, for number 5, these are 2 factors. I need to multiply 4x times this other denominator, 3x plus 2. Then to multiply 2x by the first denominator, 3x minus 2. And then my top part will be, well, I need to multiply 2 by both of those, 3x minus 2 and 3x plus 2. That's 9x squared minus 4. So that means here I get 12x squared plus 8x plus 6x squared minus 4x will equal 18x squared minus 8. I have 18x squared on this side and on the right side, so those all are going to cancel out. I'm going to have 4x will equal negative 8 then. That gives me x equals negative 2 as the answer. And on this last one, this is the factor would be x plus 3, x plus 2. So I need x plus 2 for both the top and bottom for the part on the right. So that means I'll have 3 minus the quantity x minus 6 will equal x plus 2. 3 minus x plus 6 to distribute that negative will equal x plus 2. So that means I'm going to have, I'll add an x to the right side, so I'll get 2x. I'll subtract 2 from both sides. 3 plus 6 is 9, minus 2 is 7. So that means x should equal 7 halves. 7 divided by 2. Alright, now just some basic questions. What is an asymptote? An asymptote is just a line or a curve that a graph approaches. A line or curve that a graph will approach but not touch. Will approach but not touch. That's the key thing. Now, it is possible to cross a asymptote, a horizontal asymptote, but not a vertical asymptote. What's the difference between vertical asymptote and a hole? Vertical asymptotes are when the denominator equals 0 and it does not cancel with something from the numerator. So it does not cancel. And then for a hole, same thing, where the denominator equals 0, but that factor did cancel with the numerator. So this factor does cancel to make it a hole. Okay, what type of asymptote can a graph never cross? That's a vertical asymptote. Remember, horizontal and slanted is possible. And how do we determine where a function crosses the asymptote? That's when the remainder of long division, that's when your remainder equals 0. That's when it will cross. Alright, these next questions are talking different things for each function. So, first one asks for domain of f of x. To do that, we need to factor f of x. So that's x plus 5, x plus 1, and on the bottom, x plus 5, x minus 1. The domain will be, well, we need to look at where these breakpoints are. So that's at negative 5 and positive 1. Negative infinity to negative 5 to 1, and 1 to infinity. Where are the vertical asymptotes? That's when the bottom equals 0, but where things did not cancel out. The x plus 5 cancel out, so my only vertical asymptote is this guy right here, x equals positive 1. Alright, x and y intercepts of g of x. To do that, I need to factor the top. Factor out of 4, so give me x minus 2. And when I do that, to find the x-intercepts, that's when the top part equals 0. So that's when x equals 2. So 2 comma 0. And the y-intercept is when I plug in 0 for everything. So when I plug in 0, I would get negative 8 over 4. So 0 comma negative 2 at that answer. Alright, for g of x, in the horizontal slant asymptote, to do that, we need to do long division. So to do that, I'm going to have 4x minus 8 on the inside, and x plus 4 on the outside. X times what gives me 4x? Well, it's just 4. This gives me 4x, and then plus 16. When I subtract, I get negative 24 as my remainder. Now, all I care about is just this number right here. It makes it a horizontal asymptote, and the horizontal asymptote is y equals 4. Okay, for h of x, for number 15, same thing, x-intercept and y-intercept. X-intercept is when the top part equals 0. Well, that happens when x equals 7, so 7 comma 0. And the y-intercept is when I plug in 0, so I get negative 7 over positive 7. So that means I should get 0 comma negative 1 as my y-intercept. Now, for this one, does it cross the horizontal or slant asymptote? Again, I need to do long division. X minus 7 on the inside, x plus 7 on the outside. X times what gives me x? That's 1. So that means that would be my horizontal asymptote. X plus 7 when I multiply through and I subtract to get negative 14. So I get negative 14 over x plus 7. It crosses whenever the remainder equals 0. Well, can negative 14 ever equal 0? No, it definitely cannot. So my answer here is no, it cannot cross and does not cross my horizontal asymptote of y equals 1. Alright, continuing on. We need to find horizontal asymptotes for j of x. So in this one, again, it's a long division. But in this case, we're not even going to do long division. Why? Because the degree of the top is less than the degree of the bottom. That means I can't do long division. It's like I technically already have. This here is my remainder, the x plus 8, and what would be out in front then? Well, nothing. 0 plus. There's nothing out in front, so I divided 0. That means the horizontal asymptote is always y equals 0. That's when the degree here of 1 is less than the degree of the bottom, which is 2. Okay, now does it cross a horizontal asymptote? Well, here's my remainder now, x plus 8. So I set it equal to 0, and that means I will get x equals negative 8. That's when it will cross. So yes, it does at x equals negative 8. Alright, now for v of x, we got domain. So we're going to factor both the top and the bottom. So it would be x plus 7, x minus 1 up top. And on the bottom, I should have x minus 3, x minus 1. Okay, where do I have domain issues? At 1 and 3. 1 is smaller, so it'll be negative infinity for 1. 1 to 3. And then 3 the rest of the way to infinity. Okay, now to find the holes of v of x. That's when I had domain issues and where things cancel. So that means my answer here is x equals 1. X equals 3 is a vertical asymptote. Alright, w of x, the last one we have here, I'm going to factor as x minus 3 and x plus 1. And on the bottom it will be x plus 5 and x minus 2. Vertical asymptotes are when the bottom equals 0 and does not cancel. Where nothing cancels here, so that means I have two vertical asymptotes. X equals negative 5 and x equals positive 2. Now finding the holes for w of x, that's where the bottom equals 0 and things do cancel. Well, nothing cancels, so there are none. There are no holes for this function right here. Alright, 23. We have x squared minus x minus 2. First step we always want to do when we want to do all this, factor both the top and the bottom. X minus 2, x plus 1, and in the denominator x minus 3. And I also want to do a long division immediately. So I'll have x squared minus x minus 2 on the inside, x minus 3 on the outside. Okay? X times what gives me x squared? That's just x. So that becomes x squared minus 3x. I'm going to subtract. When I do that, I will get negative x minus negative 3x, means plus positive here. So I'll have positive 2x and minus 2. X times what gives me 2x? 2. 2 times x is 2x. 2 times negative 3 is negative 6. Again, I subtract, and I should get a remainder here of 4. So my remainder is 4 over x minus 3. Alright? So now I can read off everything I need to know. My domain is, my only domain issue is here x equals 3. So negative infinity to 3, and then 3 to infinity. Vertical asymptotes are where the domain issues happen and it doesn't cancel. So it doesn't, so it's x equals 3. Horizontal asymptote or slant asymptote comes from the long division. So it's a slant asymptote because it has an x in it, so there is no horizontal asymptote. I should have said because this only domain issue was an asymptote, it can't be a hole, so there are no holes. X-intercepts at the top equals 0, so that means I have at 2 comma 0 and at negative 1 comma 0. Y-intercepts is when I plug in 0 for everything. When I do that, I'll end up with negative 2 over negative 3, which is positive 2/3. And then last one, does it cross? Well, it only crosses when my remainder equals 0. Well, 4 cannot equal 0, so no, it should not cross here. So, now I can graph everything. Let's start with the vertical asymptotes here at x equals 3. The slant asymptote is at y equals x plus 2. So I should have that slant there. Now I plot the points that I know. The points that I know are 2 comma 0, negative 1 comma 0, and 0 comma 2/3. So my function needs to cross through those points. And now I also need something on the right-hand side of this vertical asymptote. Well, if it was down below the slant asymptote, it would have to cross the x-axis again. But there are no more x-intercepts. So my only option is for it to be up here, looking something like that. Alright, for 24, same steps. First factor, I'm going to pull out a 4. I'll be left with x squared plus 2x minus 24. X squared plus 5x minus 24 on the bottom. Factor it some more. I'll have x plus 6 and x minus 4 up top. And on the bottom, I should have x plus 8 and x minus 3. I also will want to do the long division, and this is going to be a little bit cumbersome. 4x squared plus 8x minus 96. My outside is the x squared plus 5x minus 24. X squared times what gives me 4x squared? That's 4. So it gives me 4x squared plus 20x minus 96. When I do that subtraction, those go away. 8 minus 20 will give me negative 12x. And negative 96 minus negative 96 is 0. So my remainder is just negative 12. And then over, or negative 12x I should say, over x squared plus 5x minus 24. Now I have everything I need. Let's find what we need. Okay, domain issues happen at x equals negative 8 and x equals 3. So negative infinity to negative 8, negative 8 to positive 3, and 3 to infinity. Neither of these canceled out, so there goes vertical asymptotes, and that means neither of them are holes. My horizontal asymptote comes from the long division, y equals 4. It didn't have an x, that's why it's not the slant asymptote. X-intercepts, the top equals 0, so that happens at negative 6, and when x equals positive 4. My y-intercepts, when I plug in 0 everywhere, all I'm left with is negative 96 over negative 24. That gives me, when I divide that, a positive 4. So it should be x is 0, y is positive 4. And where does it cross the asymptote? That's whenever my remainder equals 0. Negative 12x equals 0 when x equals 0. So I should cross the asymptote at x equals 0. So, graphing my asymptotes first, here it is at x equals negative 8, and then I have one at x equals positive 3. My horizontal asymptote comes at y equals positive 4. From there, plot the points that I know. The points that I know are negative 6, 0, positive 4, 0, and then the y-intercept is 0, positive 4. Now that's right on the horizontal asymptote. Well, that should be good though, because when x is 0, it should have crossed anyway. So, because of this, this guy has to look like so. That's the only way I can follow the asymptotes going through that point. It's crossing the asymptote here in the middle. So connecting these 2 points, and I'm allowed to cross there, so there's my only possibility there. So I have my right section, my riddle section, I also need my left section here. If it was down here like this, it would have to cross this it would have to cross the axis again, which it cannot. We didn't have any other intercepts. So my only other option is for it to look like that up above. Well, there you have it. Make sure you just go step by step and take your time, and you'll be in good shape for all this. Thank you very much.